Hi everyone, today we're going to be going over Chapter 7. So the first thing that we're going to look at is what is evidence of a chemical reaction? Just like in the grade school volcano experiment, we knew that when there were bubbles happening that a chemical reaction was happening, but there are a lot of other things that determine whether or not a chemical reaction happens. If you have a permanent color change, a formation of a solid in a previously clear solution, so that would be the formation of a precipitate, we would call that. The formation of a gas when you add a substance to a solution, the emission of light, or the emission or absorption of heat. So sometimes when you are doing a chemical reaction, like say in an acid-base reaction, your reaction vessel will feel warm. Sometimes when you're doing a reaction, your reaction vessel will feel cool. Here is a picture of when a precipitate is formed, and here is a picture of when gas is formed. Sometimes it's easy to be fooled. When you see water boiling on a stove, you do in fact see bubbles coming out, but all that is water going from the liquid phase into the gas phase. Okay, there is no chemical reaction happening. So many times you have to look on the molecular level. We represent chemical reactions with chemical equations. The substances that are on the left-hand side of the arrow are the reactants, and the substances that are on the right-hand side of the arrow are the products. All right, we're going to specify the state of each reactant, of the reactant or product, with a parentheses next to it. So that will indicate whether or not it's a solid, a liquid, a gas, or aqueous. These are the abbreviations that you would see next to the reactants and products. In the chemical equation of methane and oxygen going on to produce carbon dioxide and water, this is the reaction without the phases of each chemical, okay? But with the phases, what state it's in, this is what it would look like. So methane is a gas, water is a gas, carbon dioxide is a gas, and the water is a gas. All right, I'm going to make this a little bigger here. So we're going to talk about balancing chemical reactions. So how many oxygen atoms are on each side of the equation? Well, on the left, we have 2 oxygen atoms, and on the right, we have 2 plus 1 more, which is 3 oxygen atoms. Atoms can't simply appear or disappear in a chemical reaction, so we need to account for the atoms on both sides of the chemical equation. If you look at the hydrogens in this problem, you have 4 hydrogens on the left, and on the right we have 2 hydrogens. So we're going to work on balancing next. In order to balance chemical equations, what we're going to do is we're going to insert coefficients. Okay, so we're going to add numbers for out in front of these chemical reactions. You don't go and change the subscripts because oxygen then becomes something completely different, okay? So we're going to write the chemical equation with each compound correct the way it belongs, but then once we're all done writing it properly, then we go and we balance everything out. So this is what our problem started out with right here. And, oops, go back. And then once we balanced it, it looked like this. And so let's explain how we did this. I just look at both sides of the reaction arrow and I see what is not balanced. So I see here that there are 4 hydrogens on the left and there are only 2 hydrogens on the right. Okay, so I can't just change this to a 4, this subscript. I can't just change this to a 4 because H40 is not water. Okay, so what you're going to do is you're going to add a coefficient out in front. So I'm going to add a 2 out in front. Okay, now the problem is that gives me, let's see, 2 oxygens on right here, and then 2 more oxygens. So I have a total of 4 oxygens on the right-hand side of the reaction arrow, but I only have 2 on the left-hand side of the reaction arrow. So what we need to do is add another set of oxygens, okay? Sometimes you'll feel like you're chasing yourself in circles trying to get things balanced, but then sometimes it works out really well. So let's go ahead and check it out. I have 1 carbon on the left, I have 1 carbon on the right. I have 2 times 2 oxygens on the left, and I have 2 oxygens and 2 oxygens on the right. So those balance. And the hydrogens, I have 4 hydrogens, okay, and I have 2 times 2, which is 4 hydrogens. So that one is now balanced. So you want to make sure after you write a chemical reaction that you do go through and you balance it out. And you'll see that we ended up with exactly what they got right here. All right, so we have some steps in balancing chemical reactions. The first thing that you're going to do is you're going to write the plain old skeletal equation is what we call it, by writing the correct formulas for each of the reactants and products. So if you guys remember from chapter 5, we went over the nomenclature rules, and we learned in that chapter how to write chemicals. Remember, you need to make your charges balance when you are writing compounds, okay? Now, if you're already given this skeletal equation, then you get to skip this step. You don't have to write it. Then you're just going to go through and you're going to balance. Okay, if an element occurs in only one compound on both sides of the equation, balance it first, okay? If there is more than one element like that, balance the metals before the nonmetals. If an element occurs by itself in a chemical reaction on either side of the chemical equation, balance it last. And then you're going to balance those free elements by adjusting the coefficients on the free elements. If the balanced equation contains a coefficient of a fraction, change these into whole numbers by multiplying the entire equation by the appropriate factor. Once you're all done, you're going to check and make sure that you have an equal amount of each element on the left as you do on the right. And remember, when you're doing this, you're never going to change the subscripts. You always change the coefficients. Okay, I'm going to start this one over. All right, so we're going to try one. Solid aluminum is reacting with aqueous sulfuric acid. Aqueous just means that you guys are going to use the little AQ as the phase that it's in. And you're going to form aqueous aluminum sulfate and hydrogen gas. All right, so let's try writing this out. Aluminum, it just says it's solid aluminum, so we have Al, and that's an S for solid. And we're going to have sulfuric acid. Hopefully you guys have been remembering what your acids are. Sulfuric acid is H2SO4, and that is aqueous because acids are always aqueous. Okay, then we have your reaction arrow, and it says that next you're forming aluminum sulfate. Okay, so if you guys remember from the nomenclature chapter, aluminum is a 3+ charge. Sulfate is a polyatomic ion, and that is SO4, 2-. That's a 4. Okay, so how would these guys go together and be balanced? Well, I would need 2 aluminums with a 3+ charge and 3 sulfates with a -2 charge, okay? That would make those balance if you did the crossover rule. So that would end up like this, Al2, and then I need to show that there are 3 sulfates. So SO4 and 3 of them. And then hydrogen gas. Now, if you remember, hydrogen is diatomic, okay? Remember the have no fear of ice cold beer. Okay, so hydrogen is one of the ones that always has to be in twos. All right, make sure I put my aqueous there. So H2 gas. All right, let's see if we came up with the right thing. All right, so we have aluminum solid with sulfuric acid, and then aluminum sulfate that's aqueous, and hydrogen gas. Excellent. All right, so now we're going to look at balancing this. All right, the first thing that I notice is that I have 3 sulfates here on the right-hand side, and I have only 1 sulfate here on the left-hand side. So remember, you always go and you change the coefficient. So I'm going to put a 3 out in front here. Okay, so it looks just like that. All right, let's see if we got it right. Yay. Okay, so what do we notice is wrong now? Well, I have 2 aluminums here on the right, 2 on the right, and here I only have 1 aluminum on the left. So I'm going to throw a 2 out in front. Okay. All right, let's check it out and see if it balances already. Okay. All right, so I have 2 aluminums on the left. I have 2 aluminums on the right. Well, I see a problem already. I have 6 hydrogens on the left. Okay, 3 times 2 is 6. But I only have 2 hydrogens on the right, so what can I do here? All right, I can put a 3 out in front. All right, so now let's look at it. I have 6 hydrogens on the left. I have 6 hydrogens on the right. Okay, I have, let's see, 2 aluminums. I did the 2 aluminums already. I have 3, whoops, here we go, 3 sulfates on the left, and I have 3 sulfates on the right. Okay, so this looks like it balances so far. Okay, so I have 2 and 2. I have 6 hydrogens, 6 hydrogens. I have 3 sulfates and 3 sulfates. All right, that is correct. We got it right. And then you can check it all out at the end. I did that with check marks, but here's another way you can do it. You can write it out. All right, I have 2 aluminums on the left. On the right, I have 2 aluminums, and so on and so forth. All right, in this next problem here, it says that you are going to write a balanced equation for lead 2 acetate, all right, with aqueous potassium iodide. Okay, so we're going to be able to get started on this video, but then we're going to finish this one out on the next video. Lead 2, what this implies, if you guys remember from your nomenclature, that means that you have Pb2+, okay? Acetate ion is C2H3O2-, okay? So how would these guys go together? Well, this is a polyatomic ion and it has a -1 charge. This has a 2+ charge, so I would need to have 2 of these guys, 2 of these acetates. So, and then 1 lead, so it would go together like this, Pb, and then parentheses C2H3O2, and close parentheses, and show that I have 2 of them. Potassium and iodine. Potassium is a plus charge, and iodine is a -1 charge. Okay, so those guys would just smash together like this. Okay, and how would these products go together? Let's think about that on the next video. Okay, lead 2 iodide. Okay, so basically these guys are swapping partners here. Your cation of this one is going to go with the anion of this one, but first you got to look at the charges. Then the cation of this one is going to go with the anion of this one. Okay, and that's going to form potassium acetate. All right, try that and then check out the finish on the next video.